Hello and welcome to this video tutorial um, about the Sigma subsurface scattering shader in the node editor in Lightwave. Um, Now, I'm not an expert with the node editor by any stretch of the imagination, so this is more of a sort of finding of my results rather than a tutorial. A tutorial would indicate that I actually know what I'm talking about. But I've been meaning to try and sort of experiment with the node editor a bit more and get more sort of affair with the settings and how to get results out of it that look like what you want. And this came about because I was checking out the Maxwell demo and came across this page on their PDF that you can download, which talks about the attenuation distance, which is the amount of light that's absorbed through a surface. And you can see this sort of object here, which is thicker on the outside and thinner on the middle. So as light is coming down and hitting this surface, there's more material for it to be absorbed into here than there is here. So the light is absorbed more, it appears darker and less translucent. Whereas in the middle here, because it's thinner, there's less material for it to pass through, so it can pass through a lot easier and becomes lighter and more translucent, and that's why we can see this checkerboard underneath. Now, as Maxwell is an unbiased renderer, which effectively means it's sort of based on as much as reality as it possibly can, at the expense of obviously render time, I'm going to use this as my sort of benchmark look, if you like. This is what I want it to look like. So I thought it's a cool scene, let's try and do that in Lightwave with the Sigma shader. So modelled up that object, so it's thinner in the middle, thicker on the outside, ground plane with a checkerboard effect, a area light just slightly behind the object, radiosity is on, and if we go to our backdrop options, we've got a textured environment with a gradient on there as well. Now let's switch to the camera view. Now it's slightly unfair to compare the Sigma shader with the Maxwell sort of renderer, because like I say, it's an unbiased renderer and it sort of does everything in real world sort of values, and Lightwave isn't an unbiased renderer, so it's effectively cheating a lot of the way, or trying to simulate the effects without the expense of render time. So this is one thing that needs pointing out initially in order to sort of get that look that we just saw, and that is when I first set this up, I had the as I often do, objects, instead of being infinitely aligned with the ground plane here, it's actually 0.1 millimeters above the y-axis, because in reality this bottom of this surface wouldn't be directly on in the same sort of plane, if you like, as this bottom surface here. So I've set this up slightly away. Now this is not going to give us the effect that we want, and I'll tell you why in a second, but if I just do a quick test render of this, and I'm going to be using the Lightwave renderer for most of this, because as I'll show you in a second, F prime actually does things slightly different when it comes to objects infinitely in line or inside of the surface here. So in terms of that Maxwell renderer, Maxwell render that we've just seen, I'm going to be using Lightwave because it gives us the results that are more similar. So let's just let this finish rendering. It renders, well, about 30 seconds apparently. Well, that was the last one. I must have done something differently. Slightly longer here. So we can see the effect happening in terms of subsurface scattering here. But this is what interests me, is it looks incorrect to me, because it's darker where it's thinner and it's lighter where it's thicker, and I would expect that to be reversed, because this is thinner and would allow light to be less light to be absorbed. If you ignore this sort of checkerboard effect for a minute, there's a reason why we can't see that here. So it's interesting that it works that way. But now if I shift this so that surface is now infinitely in line with the ground plane and do another test render, we can see that we should now start to see the checkerboard coming through. And I've actually had issues with this as well. When I've been testing this out, as I sort of get further down the test renders, I've had it where I've had exactly the same settings as this one here, and yet I can't see the checkerboard. So when I sort of quit Lightwave completely and reloaded it and not changed anything and rendered it again, I get this effect where I can see the checkerboard. So there's something happens along the way, and if that happens, I will have to quickly restart Lightwave. But we can see here, infinitely, sorry, not infinitely, this one's slightly away from the surface, and we get this sort of darkening down here, and infinitely in line. Now this looks more correct, and the reason why that is more correct is because if we go to the surface editor, bring up the Sigma panel, we have this option here, advanced shading, turned on. Now advanced shading is a set, I'll go through all the other ones in a minute, but advanced shading is particularly important for this effect here, because that allows the shader to see objects inside the surface. Now because we've got this infinitely in line, that ground plane technically is inside that surface, and that's why we can see it coming through. If I was to switch that off and do another test render, let's just pause the recording here. Okay, so as we can see, when we turn off advanced shading, we can no longer see this checkerboard underneath as we could in that scene there, and that's obviously quite predictable because advanced shading allows you to see objects inside, so you want to switch that on. Now in terms of matching sort of reality, using this as like I say, as a benchmark scene, I'm going to leave the this object infinitely in line with the Y plane here and advanced shading turned on, but we'll shift this slightly away from the surface and test stuff out as we go along to see the effects of it. Obviously this is only an issue when you have objects on a ground plane like this. If you're just doing a hand that's in air, then you're not gonna see that. So it's not necessarily an issue here. Right, so going through the settings very quickly. I mean, surface color is pretty obvious. It's effectively the color of the surface, as you would expect. So if I turn this to like a green color and F9 that again, we can see that it's changed the overall appearance of the color to green. As you would expect, that's pretty straightforward. Okay, don't need to let that render. Let's put that back to the blue color because I preferred that. The specular color is actually slightly different to the specular setting or specularity setting in the layered surface editor, in that this is the specular color and also reflection sort of color, if you like. So this is how you can tint any highlights and reflections that you might have. Now in order for that to be seen, you obviously need to have specularity off 0. But that's how you can change the look of the reflections and highlights. We'll see that in a second. Specularity is effectively how sort of smooth or rough the surface is. Now the reason I'm saying that is, in terms of roughness as well, these two are kind of linked. It's a energy conserving material is the Sigma shader, which basically means that if I have that as a 100%, even if I had roughness at 50%, the specularity kind of overrides the roughness and effectively turns it off. So in order to have the effect of both of these, that would need to be down, and then you need to obviously then play around with that setting to get it to look right. So, but that's one thing to note, is that if you want, so if we turn that to 0 and put that to 100%, so it's completely smooth surface, and then hit F9 again, you should see that it's very reflective, and renders a lot quicker as well. Now actually the reason why that is because if it's completely 100% reflective, then no absorption is taking place, because all of the light is reflected at the surface level. So it's worth pointing out that a lot of these settings are all sort of interdependent, really. In that you have to, it's a bit like